This is Justice and Mercy Energy Services.
Welcome to part 1.3. This is an advanced and an optional topic called Astronomical Parameters for Optimal Panel Orientation. So let's consider the plane of Earth's orbit. That has a special name. It's called the ecliptic. And Earth is orbiting around once per year. And we have to consider that the Earth is inclined with respect to its rotation. Its axis of rotation is inclined with respect to the plane of the Earth's orbit, the ecliptic, by 23.45 degrees. Now, if we look at that part of the Earth's orbit when the south pole is closest to the sun, we call that the winter solstice. And if we look off from the Earth at the sun, we will see that the sun seems to be below the equator or south of the equator. And that point where the north pole is closest to the sun is called the summer solstice. And when we look at the sun, it seems to be above or north of the equator. And the other 2 points here are our vernal and autumnal equinoxes. Those don't come into play quite as much. The question that we're asking, though, is what solar panel orientation will provide for the best energy capture on a year-round basis? So let's consider the Earth. We've got lines of latitude and lines of longitude. Keep in mind that at the poles it's 90 degrees and at the equator it's 0 degrees. Let's assume it's the vernal equinox in the spring and the sun is directly over the equator. Now as we move throughout the year to the summer solstice, the sun's daily motion will then go towards the north until it reaches its peak value of northiness called the summer solstice. And then it passes back through the autumnal equinox eventually to the winter solstice. And so the summer solstice and the winter solstice are 23.45 degrees away from each other. And we need to consider 2 things. We need to consider both the daily motion and the annual motion of the sun in order to orient our solar panels properly. So astronomers have developed a great tool called the celestial sphere. And the celestial sphere, you can imagine the Earth floating in space, and the celestial sphere is a sphere that it extends out from the surface of the Earth and floating in space around it. And just like we have a North Pole on the Earth, there's a celestial North Pole, and the South Pole produces a celestial South Pole. And if you look at the equator and project the equator out onto the celestial sphere, we call that the celestial equator. So the northernmost point of the sun's path on the celestial sphere is the summer solstice, and the southernmost point is the winter solstice. Now keep in mind, this is modeling the annual motion. We're talking about the annual motion, not the daily rotation of the Earth right now. Now, if I look at the angle of the sun at any particular day, I'm going to give that angle a Greek letter delta. Okay, so at 3 different times of the year, I've got shown here the angle delta. That is the angle between the celestial equator and the sun's location. We call delta the declination, and that changes from throughout the year, or every day of the year is a different declination. So the declination will be 23.45 degrees on the summer and winter solstice. It'll be positive on the summer solstice and negative on the winter, and it'll be 0 on the vernal and autumnal equinoxes. So mathematically, we could write this expression to determine what the number of degrees is of the declination at any given day of the year. N is the day of the year, so that January 1st, for example, would be N equals 1. Now on the 2 equinoxes, it's going to be either 2 pi or 2 pi times 1.5. So on the vernal equinox, it's 284 plus N divided by 365 is 1, and the autumnal it's 1.5. Either way, the declination results in 0 on the equinoxes.
Justice and Mercy Energy Services designs, installs, maintains solar energy systems in Haiti to combat energy poverty and create jobs. Consider making a donation at our website. Thanks.